a review of rational and irrational numbers and recurring decimals. So a reminder that an irrational number has two possible definitions that you might give. You might say it's a non-terminating and non-recurring decimal. So the only numbers that are going to be irrational are non-terminating and non-recurring decimals. Everything else is rational. The other definition you could possibly give for an irrational number is a number that can't be written as a fraction of whole numbers or integers. And either of those definitions is fine. But this one is the one that probably makes a bit more sense. Anything that's a non-terminating and a non-recurring decimal is irrational. Everything else is rational. So the type of question you'll get is being asked to state if numbers are rational or irrational. Now, easiest way is to use your calculator. Root 7. So the square root of 7. If you just get that, use the double arrow key and get a decimal, 2.645751311. There's not enough there to say it's recurring, and anything with a square root that's got a lot of random decimal places there is most likely to be irrational. 1/2, if you're not certain, even though we do know that any fraction has to be rational, you could do 1 divided by 2 or 1 over 2 even. Use the arrow key to get a decimal, 0.5. It's terminating. Irrational numbers are non-terminating. This is terminating. It has to be rational. This is recurring. You can tell from that. Irrational numbers are non-recurring. So any recurring decimal is rational. Pi, if you're not sure, evaluate pi, ask for a decimal. 3.14159.265. We know pi is irrational. It's non-terminating and non-recurring. Square root of 81. This is why you should always check your square roots, because that's just 9. That's terminating. So this one must be rational. So that's rational and irrational numbers. Recurring decimals are decimals that keep going in a repeating pattern. So they're non-terminating, but they recur, they have a repeating pattern that goes on forever. We need to be able to write our recurring decimals in correct notation. So remember, the steps are: identify the smallest part of the repeating part of the decimal. So here what repeats is the 4. Now it's not 44 or 44444. You want to identify the one copy of the repeating pattern and cut the decimal off after it. And rewrite just up to where you cut off and put a bar over the whole repeating pattern. So here, 1.234234,234. The repeating pattern is 234. You cut it off after one copy of the repeating pattern. You rewrite the whole decimal up to where you cut it off, and you put a bar over the whole repeating pattern. 0.8132422424. The repeating part is 24. You cut it off after one copy of the repeating part, write the whole decimal up till there, and put a bar over the repeating part. That is decimal notation for recurring notation. We can use dots instead, but it's a little bit harder. We could have done 0.4 with a dot over the repeating pattern. So if you ever see a dot, you know that means all this repeats. We also need to be able to round recurring decimals to 2 decimal places. Rounding to 2 decimal places means cut it off after 2 decimal places and check to see if we need to round up. So we'll do a few examples. 0.565656 repeating. Cut it off after 2 decimal places. Look at the first digit you cut off, the critical digit it's called. If that is 5 or more, we add a 1 to our last remaining digit. It is 5 or more, so we're going to add a 1, so I get 0.57. When you're rounding recurring decimals and they were in notation, it's a good idea to write them out first so that you can see what's happening. So I'm going to 2 decimal places, cut it off after 2 decimal places, check the critical digit, the first one I cut off. Is it 5 or more? Yes, I'm going to add 1 to here. This equals 0.89. Another recurring decimal, write it out in expanded notation. Cut it off after the required number of decimal places, which is 2. Look at the critical digit. Is it 5 or more? No. So we just leave it as we cut it off. So that's a quick overview of rational and irrational numbers and recurring decimal notation and rounding.